we're moving on to talk about polygons today, still with angles, but moving away from parallel lines and other things like that to polygons. Polygon is a shape made up of straight sides. Here is a pentagon. It's got 5 straight sides. This is the shape of a rounders pitch I want to mark out on the school field. So here's the batting position, then you've got first, second, third and fourth base. The angles I've marked here in pink have a name. They are called the exterior angles. Now we've got, with a pentagon, 5 angles inside the shape, and we're going to talk about interior angles next lesson, but the angles inside the shape are called the interior angles, but we're today talking about the exterior angles. Now it's important to note that interior and exterior angles don't add up to 360. So with the exterior angle, we're not talking about all the way around the outside, we're just talking about these pink angles, and the interior and the exterior angle add up to 180 degrees. So I start at the top here with my white line drawing machine, and I have to turn through that angle to draw that line, then I have to turn through that angle to draw that line, I then have to turn through that angle to draw that line, another angle to draw that line, a final angle, and I'm back where I started. And you will note that the 5 exterior angles all added up to 360. Now you might be saying, well, that's just a coincidence. What about if it was something other than a pentagon? So okay, let's do a hexagon, all right? And this is a regular hexagon, so I'm going to make it irregular. So regular hexagon, all the sides are the same length. Irregular, they are not. Let's do the same thing. Here we go. Again, the exterior angles add up to 360 degrees. Now I drew that shape clockwise. Have a look at the pink angles as I change from clockwise to anti-clockwise. If I decided to go around the other way, the angles are the same size. They haven't changed size. They're just now the other side of the corner, and they still add up to 360. Okay, let's move up to an 8-sided shape, an octagon, and this time I'm going to leave it as regular. And what you should notice now is that all of the angles are the same size. So they're still going to add up to 360, but this time they're all the same size. And did you notice how big each angle was? They were all 45 degrees, and we could predict that, couldn't we? Because we know that the exterior angles add up to 360 degrees. With an octagon, there are 8 of them, all the same size. 360 divided by 8 is 45 degrees. Okay, so here are my 3 bubble-worthy facts. So in any polygon, the exterior angles always add up to 360. In a regular polygon, each exterior angle is the same size. And whether you go clockwise or anti-clockwise, the exterior angles at each corner are the same size. One other fact that I just want to remind you of for today's work is that the interior angles, the angles inside a quadrilateral, not a polygon, a quadrilateral is a 4-sided polygon, they always add up to 360. Hopefully that's a fact you remember. So let's look at 3 questions. So firstly, here is a regular polygon. I can only see a corner of it. So this is one of the interior angles of that polygon. And here's the exterior angle. So this gives me another bubble-worthy definition. Interior plus exterior at every corner of a polygon equals 180 degrees. They all weigh that up to 180 degrees. But my question is, I can only see a little bit of this polygon. How many sides has it got? If I tell you that the exterior angle is 60 degrees and it's a regular polygon. Well, we know they add up to 360, and if it's regular, they're all the same size. So 360 divided by something, the number of sides, is going to be 60 degrees. Hopefully you can see that's 6. So what we've got here is 6 sides. So we've got a hexagon. Here's another sort of problem. How big are the exterior angles of a regular decagon? Now, a decagon has got 10 sides. Well, here we are. They always add up to 360, and in a regular polygon, they're all the same size. A decagon will have 10 of them. So 360 divided by 10, 36 degrees. So each exterior angle for a regular decagon, 36 degrees. Okay, lastly, I've got here a quadrilateral. It's a trapezium. It's a special sort of quadrilateral. It's got one pair of parallel sides. In fact, it's even more special than that. It's called an isosceles trapezium, 2 equal sides. And that means it's got a particular property. It means that the 2 base angles are the same. And these 2 angles here will always be also be the same. Now, those two, 65 and 65, add up to 130. I know I've got 360 altogether. So if I do 360 take away 130, I get 230. So that's what those 2 angles there add up to, and they're both the same. So they're both going to be 115. And the question is, where will I find the biggest exterior angle in this shape? Well, firstly, you need to decide if you're going clockwise or anti-clockwise. So I'm going to draw this shape in a clockwise direction. So I'm going to start here. If I draw there, that's my first exterior angle. I then draw here, that's my next exterior angle. I then draw up here, that's my next exterior angle, and then I draw along here. This is my final exterior angle. So if I look at those 4 angles, I hope you can see that the 2 here are the biggest. These 2 are smaller than 90 degrees. These 2 are bigger than 90 degrees. Remember the bubble wave effect up here. The interior and the exterior angle add up to 180. So if that's 65, 180 take away 65, that's 115 degrees. So the biggest exterior angle in that shape is 115 degrees. Okay, so I've attached a single page worksheet with a number of questions relating to exterior angles, and I'll be absolutely frank with you, if you've listened to those 3 examples, then you will be able to answer all of the questions on that sheet. And the answers are on the second page, but please don't, there's no point just going straight to the answers. Have a go at page 1 yourself, then check the answers. If you've watched the whole video and you can't see where the answers come from, then by all means get in touch and I will be delighted to help you. Well done to those of you who have submitted from last lesson. Can I please get the stragglers to do that for me? And you'll hear from me again on Friday.